Thank you very much for the engaging introduction. My name is Leif. I'd like to talk about a prototype demonstrator that we've built as part of a German research project, which came around quite nicely at the moment, and want to talk about the experience that we gained from building that and maybe see if we have some reflections at the end. It's a project from the German 5G innovation program, part of the German 5G strategy. They were trying to have tangible use cases, and we proposed building a use case around the industry campus in Troisdorf, which is a city near Bonn and Cologne. I'll come to that in a bit. And it's one of the work packages features a mixed reality and virtual reality use case that uses machine data from one of the project partners that's also used in the production line of one of the other project partners. So let's see how that went. It was showcased, as was already hinted, quite a lot last year. So we've been a headliner at Fraunhofer's booth at the Hannover Messe Industrie earlier this year. We've also been repeatedly invited to the structured dialogue about immersive media Metaverse by Bundesministerium für Digitales und Verkehr, the German Digital and Transport Ministry, and also subsequently at the German government Open Day as the exhibit of that innovation program. This is Troisdorf. It's a small city between Cologne and Bonn. It has everything nearby, which is cool, and it has a very distinct industry campus, which many small cities probably would like to have, because they've got lots of industry that pays lots of taxes and do lots of cool stuff. And also it is the former Dynamit Nobel, you know, the dynamite from Boom, and Nobel from the Nobel Prizes. And it was kind of 20, 30 years ago they privatized that into smaller companies. And several of those companies are still on the campus and are project partners. So the idea of the government was they asked for concepts, which we got one of the concept fundings, which was nice. So we didn't have to come up with the concept on our pocket money, but could actually work on that for quite some time. Then we were selected as the North Rhine-Westphalian use case, if you so will. So I put it on the map, and you see the other 9 funded projects are at least 3 hours drive away. From our self-reflection, we think we are quite well fitted because we have networking technology knowledge from our communication engineers. We have the mixed reality expertise from my group, and we also have the cooperation systems knowledge from the department that we are located in. So at least that's what we think. That's the project at a glance on one page. It's a 3 years project that has been extended to 42 months. We got roughly 3.5 million euros. We've got 2 major use cases. You see the forklift there, which I'm not talking about today, which has IoT sensing and stuff, but that's that. And then we've got the remote maintenance use case that I want to elaborate on in this case. And we use 5G when it's available. I'll come to that also, and see also what it does to the workforce, how it changes their work, and what we can do with that. Our role from Fraunhofer FIT is to coordinate everything and do a lot of the development and help also with the evaluation. I'll start with the video that we presented at CAI this year.
The video presentation of our CAI 2023 late-breaking work called Industrial Metaverse, Supporting Remote Maintenance with Avatars and Digital Twins in Collaborative XR Environments. We provide 2 interfaces, AR and VR, into a shared digital space that is linked via digital twin CAD models from the machine manufacturer who is a project partner. First, let's have a look at the augmented reality side. Here's a worker at a machine on a shop floor. He's wearing a HoloLens and a bone-conducting headset that also works in noisy environments. This is what he sees, a high-fidelity digital twin and the avatar of the remote user. Notice the rendering quality, which is far higher than what a HoloLens could render locally. This is made possible through remote rendering over fast wireless networks. The worker is instructed by the remote user. Here he is mounting a blade. Now let's have a look at the remote user, who could be thousands of kilometers away from the local user. He's wearing a virtual reality headset. He meets his communication partner in the shared space, where they have a video and audio connection. In addition, he also sees the digital twin and the avatar of his communication partner. So he knows where his partner is positioned and what he looks at. He also sees his tracked hands and what he is doing. Here you can see the remote view of the local user turning the model off and on. Please note how the gestures match nicely between the video chat and the hand of the avatar. The remote user can also move parts of the digital twin to show how things are done. This is joint work with our project partners. For more information, please check our paper, visit our website, or talk to us. Thanks for watching.
Okay, so that should give you an impression of where we are at. That's last year's prototype. We did quite a bit of improvements over that, but that's where we are, and that's enough for the talk already, I guess. So I want to take you on the journey, how we got there, kind of how we organized our work and what we learned from that. So when we started in early 2021, we kicked off with several strands of work in this work package alone. So one important step was that we made the industry partner the work package leader, and he also kind of owned the process and got us into weekly meetings, and so he tossed us through the process other than other way around, which we think is quite important. We conducted some workshops on demand. Initially, we would have liked to have lots of more workshops on site, but Corona permitting, we could only do so much on site. But also, in a way, it helped us because this is a remote maintenance use case. So using Teams and stuff is a natural aid towards that goal in a way. So it wasn't all bad. We did lots of technical tests. We studied available literature and also looked at the marketing and condensed everything into a design document that helped us formalize our work. We also looked at the processes in the company a priori, so what they were already doing, and we did interviews with the managers and the personnel to find out what their work is like and also what is taxing to them. This is meant to then later compare, before and after. That's going to be at the end of the project. And we also did a psychological stress analysis with some newly made questionnaires called psychische Belastungsanalyse, so German PBA. But that's psychological stress analysis that our social science partner developed with mixtures of existing questionnaires and added questions. So we put NASA TLX, for example, but also our own mixed reality evaluation methods from prior big European projects or other projects that are mentioned down there. And everything was done in quick iterations. I put the iterative development cycle up there. I'm sure you know these things. Test quickly, test often, and so forth. We allowed ourselves to not be feature complete, but to test small bits. So in the first iteration, of course, we had lots of obstacles. A big obstacle was that the industry partner had to earn money. I mean, we have industry partners that did their first research project with us, and they are already market leaders. So they don't need the research projects to subsidize their existence. For them, it's rather a hindrance to be in the project, juggling with their time in the same time as they have to do the business. So that's something that we have to deal with, and that's a good sign, I guess. We also had a mountain of technology that we had to decide upon. I mean, if you look around on the expo fair here today, there's so much technology, and there's even more, so we had to wade our way through that. Then we are a 5G project, mind you, and 5G wasn't available in 2021. If you've got 5G on your private mobile phone or your business mobile phone, it's very probably not 5G, I'm sorry, it's 4.9G, so it's a turbocharged LTE network. The real 5G will be marketed as 5G plus, yeah? We had to order a 5G network. We had our communication technicians that knew exactly how to do it and what to expect, but it wasn't easy to get the orders in. Mind you, we are a big research organization, so when we want to spend the money, we have to do a public tender for that, and people have to reply to us, the companies have to reply to us. And for example, I gave a different talk about it, it's not a topic today, but if we ask for, let's have about 10 milliseconds latency, you get, yeah, you can have 35, okay. And we want to have a release 16 5G, please, with an option for release 17. Yes, you can have release 15, okay. Yeah, so you have a matrix that's filled quite unsatisfactory, and between that, you have to pick the winner. We got one that we chose that was the best for us, and in the end, we went for an Open RAN-based approach, which is okay for us researchers. It's not perfect, but it works reasonably well and gives us the best shot for the money at the moment. Also, there was a ship crisis, if you remember, and depending on your pronunciation, that will be the silicon ships or the ship in the Suez Canal that also blocked the supply from Asia. And we felt that when you were buying chips and we couldn't get them, but it worked in the end. Yeah. But the first year we didn't have the 5G. It only arrived at end of 2021, and we couldn't possibly wait a year to just continue working. Why shouldn't we? That's why we put it into small packages. And so in the first year we didn't use 5G at all. Actually, we didn't use any network at all. We made it a solitary experience on a single device to just learn about the processes that the company is doing. And so we decided to make a checklist-like training application that renders locally on a HoloLens 2. And we looked at export workflows from the CAD workstation and so forth. And we also wrote early papers. So I mentioned a workshop paper here in the picture, which helped us to get a common understanding between the technicians, the industry partners, and the social scientists, which all have different lingua. So here's an example from the file format that I mentioned. It's a reality. You know, if you export something and it doesn't work, you all know it from whatever workflow you have. They have the same problem in CAD. So on the left side, we've got our industry partner, the machine manufacturer ZWI Technologies. They work with a CAD software called SolidWorks, and we wanted to use Unity for some reason. And between them, there were several exchange formats, so we wouldn't have the structure of the objects in STL. We could have used OBJ, which is a widely used, very simple format, but it didn't have any kind of textures or animations, so that was out as well. And actually, we decided to use a simple model first, so that's what you see there. That's not the full machine you saw in the video. It's a simple part, but it had several parts, so that's what we tested. This is what home office looked like for a mixed reality developer of my colleague, and we were checking the interactions that we can do with the models that we got from the engineers, and that was fine for us. Yeah. Then there was another file format that was working even better, so we got colors and animations by using a GLB and GLTF. That's good enough for us for this project. In the future, we can investigate if maybe a USD is going to be better, but for the moment, we are fine with that. You can only do so much in one project. Then we had to get the data in, so not only the data about the model, but also the data about the processes. How do you actually repair such a machine? For that, they gave us a video that you can see down there on the left side, which they already produced because, you know, they had all the 3D data, so they already did that in the past. So there's a very specific key part that we will come back to later. that you see in the video. Unfortunately, there wasn't a script available anymore. They had the video, so here's the video. We're like, yeah, do you have the script of the steps? No, but we can tell you. So we kind of reverse engineered some very simple steps from a very articulate 3D rendering, which was cool. It helped the process. It just felt a bit unbalanced to have the full-featured 3D movie and not having the instructions available, but happens. On the top, you see some device comparisons that we did. I'm hiding all the details. I'm not boring you with all of that, but we looked at quite a few developments. This is what we had at year one, so you can see the machine. It looks different than the one in the other video. It's the same machine, but this one has the housing. So this is in the production line. The other one was on the ZWI Technologies campus. This is Kurerei. We were quite satisfied that we were within a couple of centimeter precision. That's definitely a working resolution for us. And in the initial prototype that you see on the left in the video, the checklist was still kind of a process that you clicked through. If you look at the right side, you see that we changed the interface because the steps were actually not chronologically, so we turned it into a checklist. And so that's the two interfaces we had in the first year there. But it helped you getting around the machine and learning tasks to do, in this case, how to clean the machine, which has to be done on every shift. There's a lot of dirt coming out of the machine that needs to go. Facebook decided to rename to Meta in October 2021 and asked for everyone to join them on the crusade to the Metaverse. In the same time that they had some problems about whistleblowing, about democracy problems with the brand, but that's another topic. So when everyone was starting looking into that new endeavor, we already were in the lucky position that we had something to show about. The use case was originally called a 5G mixed reality suitcase because that explains what it does and what it contains, but it actually also has a lot of aspects of an industrial metaverse application. So we happily call that an industrial metaverse after some literature review and checking what is a metaverse. It's difficult. Nobody has a real definition until today. But as time went by, we came around a lot with that. We published our definition and the review of some of what we thought would be relevant academic literature in that paper that mentioned there. And for us, the metaverse has AR aspects as well. So if it's only VR, it's okay, but we are not so interested. And all the other aspects are listed there. Second year prototype, you've already seen it in the video. Here's just a short explaining you the two different users. So on the top left, you've got the technician at the company. In the top middle, you've got the on-site user that needs some support. And you see their views in VR and mixed reality and also each other's representations in avatars. For avatars, there's many options on the market. For us, Ready Player Me was good enough. We didn't need the legs for anything. Hands were helpful. Deictic gestures are very useful for interaction and presence, as we know from prior projects. And so that's what we went for. Then we had to do the remote rendering because the machine model is so much more complex than what the chosen HoloLens 2 could render. We looked at different suppliers, partially under NDA, so we can't talk all the details, but I can say not everything worked as it said on the tin. And in the end, we were quite happy with Azure remote rendering for the time being. At the time of selecting this technology, it only supported the HoloLens. Now it also supports the Meta Quest. Probably everyone checked the Meta Quest 3 here or prior or will very soon. It's a cool device, so of course we also use that in the future because it's also a lot cheaper and available. The remote rendering here is a cloud-based approach. versus your self-hosted approach. There were different pros and cons to both approaches. We decided for a cloud-based approach because we thought it's actually more secure if you acknowledge that it's going to be someone else's server, but probably that someone else's server is more professionally maintained than your own server if your admin also has to run another server with another set of patches. And it was also more economic in our use case because we didn't have to pay for the server and for the expensive software license and so forth, but rather paid for pay-per-use. And our industry partner, of course, also looks at the costs, because that's what they have to do as industry partners, and that worked for us. But the major point was that the industry partner already passed Azure IT clearance, and if you've done an industry IT project, you know that IT clearance is a big thing that can be a showstopper, and it was already passed, so that was a big tick in the box for us. And now we can render tens to hundreds of millions of polygons, which is cool. So in this second year, so I'm approaching the video now that you already saw. We tested the new solution with the remote rendering and everything. We tested it in our 5G test network at Fraunhofer FIT, but we also tested it on site because that's where the evaluation was going to take place. And you can see that the left machine is what you see from the video. If we augment it with the housing, it resembles the other video, so it's just housing. Here's another video that shows you the level of detail that the machine has, and maybe you recognize this wrench here, this special part that I mentioned earlier, and it's just all the details. We don't strive for any kind of photorealism because it doesn't help, according to our own prior findings from big European projects. Since then, because this is last year's prototype, we rather focused on not always rendering everything opaque on top, but having a bit more of an X-ray vision and being able to turn stuff off and on, because as soon as you know that this is the part that you have to work with, you don't need the augmented reality for that moment. It's in the way, so that's what we concentrate on. And that brings me on homing in. So a couple of challenges that we faced were the multi-user implementation. If you've done anything like that for yourself, you know it's cumbersome, syncing everything between clients that might even be running on different devices or maybe even different operating systems, but using something like Unity definitely helps a lot, but you can also use Unreal or any other technology. The remote rendering, it's existing solutions, but still it's a lot of effort to integrate everything and also to get the workflow from the engineer to the rendering solution. Avatars Enhanced didn't come for free. I mean, there's ready solutions, but still you have to integrate them, and then there's all this user interface and user experience stuff that you have to implement with VR and also with AR. And yeah, it's all very complex, a lot more complex than your typical web application, and testing is also cumbersome. This is a view of our main developer testing two sides of the interface at the same time, because the emulator doesn't help. So he has to look through the MetaQuest and the HoloLens to see if everything is all right. So yeah, that's live. Just recapping here on the exposure that we got from the project. That was then deemed as a good industrial metaverse exhibit for the German ministry. Facebook renamed itself to Meta. There were different fairs that we were going to and invited to and continue to be invited to, and got lots of attention for that in Germany. There's a Bitkom, that's the German Industry Association working group on these topics. We contributed to that and to those reports. Different events, won't read them out, they're printed there. A couple of invitations discussing on stage with Meta and others about, what it could all mean. And I don't know the answer to these things, but maybe have a quite good understanding to some parts of the problem. And then all these ministry dialogues, and they piled up. So we got the German Digital Ministry inviting us. We've got the German Economic and Climate Ministry, BMWK, Wirtschaft und Klima. They also work with Metaverse things, and they discovered they needed some joint meetings, so we were also invited to those as exemplary project. We went to Hannover Messe, already mentioned that. We had the paper where you saw the video from. We got visited by, German major television and so forth. We are ongoing checking what it actually means for people if they're exposed to this kind of technology, and also what it means to the organizations that those people work in. That's ongoing work, despite all the technological improvements. And I'm not going to read out the different dissemination. We were there. We have a rich history of CSCW, which is computer-supported collaborative work, everything we do with our computers already, and human-computer interaction, HCI, in Europe specifically. And we've been seeing that merge with mixed reality over the last 10 years at least. And you see the AWE has been running for that amount of time. There's a lot of potential for that in all kinds of industries, and specifically for us, not only in white-collar workers like us, but also with blue-collar workers. We bring it to the shop floor. There's a lot of prospect for that. We see ourselves in the tradition of Fred Brooks Jr., a computer scientist, as the toolsmith, so we make tools for people to use. And if we wanted to see what the Metaverse might be like, of course, you heard about Second Life doing all of that 15 to 20 years ago. But for us, we are not so interested in the VR only. For us, there's the connection to the real world that can be helped with digital twins and avatars. European capabilities. We have the multicultural history, which is actually our strength, and peace holder, as good as we can. That's the success story of Europe over the centuries. We've got a world-renowned engineering and production capabilities here. And sometimes people forget that the web wasn't invented in California by big tech, but by an Englishman in Switzerland. And we have to come back to that self-assurance that we actually do these things quite nicely. We just sometimes have problems selling it correctly, maybe. So here's to that. And now we also have the GDPR, which forces us to be a bit more data scarce, not giving everything to big siren servers, as Sharon Lanier would put it, which is the business model of big tech, obviously. So that's what academics call surveillance capitalism, because you pay with your data and you're being supervised all the time. We've got the participatory design tradition that's coming down from Scandinavia with a change in legislation in the 1970s, where workers suddenly had the right to have a say on their working conditions, which was a new thing back then. And also that was accustomed in Germany and many other countries, and led to the developments of groupware on computer-supported collaborative work. And now with mixed reality, XR technology, also with the work that I've been presenting here and many others. We have to be human-centric. That's what I believe in. And we also have to be iterative, because you cannot do it in one go. And maybe if everything goes right, we can help German SMEs, small, medium enterprises, to provide interactive services on a digital twin in a metaverse-ready fashion for the future, but having an eye on the national regulations as well. And if that's working, we have to be quick anyway, and if something breaks, we are a bit sad, but let's just buy another set of glasses and be happy. Thank you.
Thank you so much. Let's just buy another pair of glasses and be happy. Wonderful. Okay, everyone. So, we're about to wrap up. Got any questions?
If you want to take the leaflet, it's near the cameraman, actually, so the use case is described, and you can watch the video at home if you like. But it's a DIN A4 paper, so it's quite big.
Okay. We're all daydreaming a bit here, all right? So, any questions? Any thoughts? Yes, of course.
Hello, nice talk. You have mentioned you have done or you are doing currently some studies on what's the effects on the workers and what are the stress levels. Do you have some results that you can share with us, some preliminary results, something?
Preliminary results. So the evaluation paper is in the process of being written. So what can I say? For example, I was surprised that using the camera, which has some surveillance aspects, in my understanding, is actually not a problem on the shop floor, because when they go to work, they're being filmed anyway. They don't mind being filmed by mixed reality glass. That was one learning for me personally, but I'm from another background. I'm not a blue-collar worker, so that seemed to work. Also, we found that the remote experts, so the people that have the knowledge about the machine, can get accustomed to technology quite quickly. So even when it's kind of new, like in the expo fair, you try something out, okay, you're a bit hesitant for the first try. If they did it the second or third time, they became very authoritative and run around and go like, okay, here, there, and show you this. And they were managing and mastering the space. So that seems to work. That's what I remember now that I can tell you already. And the paper will be out hopefully early next year. Thanks.
Okie dokie. Any other questions?
Everybody wants to see the wrap-up with Orienba, huh?
Yeah, I think
and I don't blame you.
we've had a pretty long day, I suppose.
Yeah.
I think that would be. Thank you so much. Thank you so much, Leif, for your presentation. Big round of applause.